Good afternoon. Welcome to my presentation, Think Big. I would like to tell you a little bit about serverless architectures, how you can architect, design systems that do not rely on servers, but that do it differently. And this is very helpful if you have workloads that you cannot really estimate how much traffic, how much users you will have. Let me start with a little bit of background about myself. I'm with AWS Professional Services. I'm working with enterprises, mostly in Germany, and help them build systems that are serverless, that might be agile, that you can develop with a DevOps approach. Before that, I worked for startups, helped them build these structures on AWS, and before that, I spent about 10 years in academia building highly scalable, highly reliable, fully decentralized systems. Let's have a small case that we try to architect together. Assume Hannibal is making a business with renting out elephants to people that want to transport goods. And these elephants report their position and other telemetry data once per minute. How do you do that? Well, you take a data center and you put an instance into that data center, and this instance costs you a little bit. It's not much. It's $90-something per month if you take an M4 large, and this system can then process the reports that come in from the elephants. When you start the business and there is not much business for you, then it is very expensive if you consider the cost per report that comes in from your elephants. If you do it daily, it would be $3 per report that comes in. If you have 100 reports, the cost per report will go down. It scales down, but you have to pay the money, have to pay a lot of money, regardless of how much business you do. And the important question here is, how much business do you expect? How much elephants do you rent out per day? 1, hundreds, 1 million? You don't know. And likewise, you don't know how much your instance that you have just launched can process. Is it enough for 1,000 elephants? Do you need more instances for that? You have to try it out. And this makes it very difficult, especially if you want to write a business proposal. If you have to see about the numbers, if ends match, if you can actually do that business. This is difficult. Now, let's consider why this is difficult. The problem is that you are thinking in boxes. You have a box and it has a certain volume that it can hold. And as soon as you have more traffic than fits into that one box, you need another box and yet another box. And this makes it difficult. Let's consider for a moment there are no boxes. Let's think outside the box. Let's assume there are no servers. And if there are no servers, there is no sizing. The world is yours. You can do your business and you do not have to worry about the boxes. Let's see how we can do that. And one way for this example to do it is AWS IoT. So we equip the elephants with a little bit of hardware that can report the telemetry from the elephant to the AWS IoT system. And then you have an AWS Lambda function sitting next to the IoT rule engine, and that Lambda function can then process the things. How much does that cost? Well, for AWS IoT service, you have $5 per 1 million messages. So if you have less messages, it is less that you pay. If you have more messages, it's more. The per message cost is $5 divided by 1 million. So it's tiny what you pay. And then you need a little bit of processing, say a Lambda function that needs a little bit of memory, that runs a little bit of time, and that, in this example, would cost you about $1 for 1 million messages. And this is very helpful if you do not know the size of your business, if you do not know how much one box can stand, because you can quickly build the system, you can experience what this system is able to do, you can improve the system, and you pay only a tiny fee, at least in the beginning. If you scale out your business, you will pay more, but then you have customers anyway. And then you have a business that brings the money that you have to pay for the processing. It's not that you have to make a huge upfront investment. It is just that you pay on the go. You pay for what you use, no boxes. That's the power of the serverless approach. Let's have a deeper look into the architecture. What have we forgotten about the architecture here? There's something missing in the example I've shown you so far. And the thing we have been missing is the persistence. These reports do not just need to be processed, they also need to be stored. At least some information of the reports needs to be stored. How can we do that? Okay, we have several methods to store that. We can put the data on S3. We can put the data into DynamoDB. We can put it on an RDS database. And all these different storage technologies come with a price. And I have done the math for you, and here is the price. So if you want to store the data, in this example, on S3, it's about $0.50 per month. If you store it in DynamoDB, it's $1 per month. If you store it on RDS, it is $150 per month. You see the difference. Of course, the systems have different capabilities. They have different ways of storing the data. But if you think about slowly scaling out your business, then these numbers matter. Because for an RDS, you have to pay the money regardless of how much data you actually store, how much transactions per second you actually have. If you go to Dynamo, you are much better off if your business is small, because you can even for $1 per month do something meaningful with DynamoDB. And if you go to S3, you have even a different, yet another price point for that storage system. Okay, let's have a look at the architecture. So we have the elephants sending data into the IoT rule engine. We have a Lambda function processing that data, and then we have DynamoDB storing the data. The traffic that we expect, say it's 1 million messages per month, just to get an easier grip on the math here. And then we will have $5 for the IoT ingestion, $1 for the Lambda processing, and $1.50 for the storage there. So nice little business that you can get started there. Okay, now your business is successful. Now you have a new branch opening, and they come with 100,000 camels reporting data into your system. 100,000 camels reporting telemetry once per minute. The system can stand that. But let's calculate the price. What will it cost to have 100,000 camels report once per minute? So, okay, I went too fast. So, if you have that and do the math, it is 4.3 billion messages per month that you process. How much will that cost? If you do it with DynamoDB, it will cost you $950 per month. It's okay for a business of that size, but it is way more than you paid in the beginning. If you process the data with the Lambda function the way I showed you, you pay nearly $4,500 per month for that amount of messages coming in. Well, that's getting substantial for your business. If you, however, put a Kinesis in front of your Lambda function, then you gain the ability to batch process the data that comes in. You have now the ability to process up to 1,000 messages in one Lambda execution. And this gives you a different price point. Let's calculate, and we see we have the same amount for the Dynamo. We did not change anything there. We have to pay for the Kinesis, about $90, but we lower the price for the Lambda by a factor of 100 in that example, assuming that we have only a little bit of processing on the messages that come in and that it's actually realistic to process 1,000 messages in a bunch. We have done these projects with real customers and real vehicles, and then you see that these numbers are actually right in the cases that you see in practice. Just to give you a feeling what you can do with these systems. Okay, that's the architecture, and that's the cost that you will have for that. It is roughly 1 cent per camel that you have to pay for that architecture. So 1 month coming in, all of these data, doing a little bit of processing, a little bit of storage on your system will be at that price point. And now the question is, can you do it even more cost efficiently? Let's see what we can do here. When I showed you the different storage technologies, I missed one out. So I did talk about RDS, I talked about Dynamo, and I did not talk about ElastiCache. So who of you has heard about ElastiCache? Oh, a few here and there. Who has used ElastiCache? Oh, also some people. That's very good. Because ElastiCache sits at a nice sweet spot in the cost and performance trade-off that you have in storage technologies with AWS. In the example we had, the ElastiCache would be at $134 per month. So it's slightly cheaper than RDS. It is way more expensive than Dynamo, given that numbers in these examples. But the important fact is in the performance of that ElastiCache thing. So far, we have been entirely serverless. So it was almost entirely the variable cost of the messages that you ingested. There is a small capacity fee for Kinesis, there is a small capacity fee for Dynamo, but the rest is serverless. It scales linearly with the amount of traffic that you generate in this system. Now we slightly move out of the serverless architecture and put a tiny little ElastiCache into the picture. If you are talking about a small business, just a few elephants, this would not be the right architecture because you have that $134 that you have to pay regardless of the traffic that you have. But if you're thinking about 100,000 camels, this might be an interesting price point. Let's see what we can do with that. So we have, this was just the example we had before, and now replace the DynamoDB, $950, with an ElastiCache. $134. This is way less expensive than if you just do it plain with Dynamo or plain with S3, for example, because you have that huge amount of traffic that this elastic cache can handle. And taking these numbers, you will see that this elastic cache instance that I put here in the calculation, and it's not the smallest one, that can handle a lot of traffic. So actually with 100,000 camels, it would be very lightly loaded, 3% of its capacity only. So you can still scale out your business. So if you have not just 100,000 camels, if you have 1 million camels, no problem, the system can stand that. If you have 2 million or 3 million camels, the system can stand that. If you scale beyond that, put another elastic cache. So this is an architecture that scales out nicely to even large systems. Now, let's do the math. We are now at $0.25 for that setup in the worst case. So if your business grows beyond 100,000 camels, this value will again go down. Remember, in the serverless world, it is almost entirely variable cost. If you put in boxes, you introduce fixed costs because you have to get the box up front. So now we are slightly back into the server in the box business that you have to right-size it, but on a level where you can really afford it. So I doubt if you are in a business that you have services for 100,000 vehicles that you would care about $100 per month. My assumption, and I've seen customers not having these worries here, being very happy about the architecture that you have seen there. Again, have we missed something? What have we been missing out in that example? Yeah, there is the persistence problem, because elastic cache is just a cache. It does not guarantee to hold the data. If something bad happens to your elastic cache, the data is gone. So it's nice if everything works well, but it's bad if something screws up. Can we fix that? Yeah, we can. Let's put a little bit more around that architecture. So we have already had the Kinesis that ingests all the data. Then we have the Lambda function that reads the data from the Kinesis in bunches. A lot of messages in one processing, up to 1,000. And an elastic cache where we just store that hot data that is likely to be queried within the next hour, within the next day, within the next weeks. And besides that, we make sure that we move the data to another storage technology, be it Dynamo, be it S3, where that data is persistent, where we can be sure that the data will be there when we need it. If something bad happens to your elastic cache, go back to S3 and read it from there. And the reliability of S3, the durability of the data is very, very high. A lot of nines behind the comma. So, if something bad happens, you can go back there and read it. But wait, we had the problem that it is not cost efficient to write every data set directly into Dynamo or S3, because you pay for all these little calls. This is serverless. Each call costs a tiny little fee, and if you have millions of camels, these fees add up. That was the reason why we put in the elastic cache. What can we do about that? And the trick that helps us here is that Kinesis holds the data for 24 hours. You can even increase that. Assume it's 24 hours. So just the basic plain Kinesis that we have. All we have to do is to move that data into elastic cache when it crashed and to move it eventually to S3 or Dynamo where it can be persistent. So the scenario is as follows. We have that elastic cache that hopefully will run fine all the time. In case something bad happens, we go back to the Kinesis, pull the data from there, back into elastic cache, and then we are back in business. At the same time, we take the data from the elastic cache and put it also into S3 or Dynamo, so that we can this data that gives us the historic data also back into elastic cache. So this is the cold data. And in the business cases from the real world, this is actually what you want to have. You want to have a lot of hot data where the people can actually see how is my camel doing today, and you want to have the aggregated historic data that you can trace back, oh, that camel is feeling sick. Maybe there was a problem even a few weeks or a month ago. Let's have a look how that camel behaved back in time, and you can go back to the cold data and see that. This is the design that combines the durability of the data with a very low cost of this mostly serverless approach. Okay, what else could we add to that architecture? What is missing in practice? And the problem about these camels is that they cross the desert. And there is very low Wi-Fi coverage in the desert. So it is unlikely that these camels will have a chance to transmit their telemetry data into the AWS cloud while they are traveling through the desert. They will eventually come back to some oasis here or a share or a city, and then they can upload all their data that they collected, but this will be a lot of data that they just ingest at once when they are safe back in their harbor. What are we missing, or what should we add in this case? Well, if you have a lot of data, it would be expensive to have a lot of messages go through that Kinesis pipe into the Lambda function to be processed there. Because remember, the serverless is paying per message. If the camel comes to the oasis, it will have to send a lot of messages. Expensive. If you send it to S3, you can upload a lot more data. And here's the math for that. So if you send 1 million messages to AWS IoT, you will pay $5. If you send the 1 million messages to S3, you will pay a little bit more, $5.40. But the difference is the amount of data that you can put into these systems in one message, in one upload. For AWS IoT, it's 128K. For S3, it is a lot more. Let's just assume it's 100 meg. So it could go even higher than that, but it's not really recommended. And you see there is a huge difference. Again, you have to look at the architecture, what you want to achieve. If you have a lot of data that you upload when your camel is back into the oasis, into the city, use this way. If it's en route, if it's traveling, and you have the ability to upload the data, satellite link, whatever, you do it with IoT. And these are the trade-offs that make a good architecture. And again, as I said, the underlying system are several real cases that you can build with exactly that technology. Okay, what's missing? So we have the IoT, we have the Kinesis, we have the Lambda, we store the hot data in elastic cache, we store the cold data in S3 or Dynamo. What's missing? Oh yeah, we want to read the data. So someone wants to read the data. Someone wants to know how their camels are doing. Where is that nice camel I met yesterday? How are these camels doing? What's the average performance of my camels? We need to get the data back out of the storage systems where we put them. Okay, very easy. So this is a typical use case for API gateway. We put an API gateway where we create some REST calls that can query for the camels. Give me the data. Give me the hot data from Elasticache. Give me the cold data from Dynamo. Give me whatever I want. And we can structure the data in Elasticache and Dynamo and S3 in just the way that it matches the interface that we have on our application that we want to present to our customers, or you to your customers. You can exactly create the system that serves your need. And this is the recommended architecture, my recommendation of an architecture for you. You have some IoT device. It sends the data to Kinesis if it's a small message. It sends the data to S3 if it's a huge message. It has some Lambda functions processing the bulk data, the bunches of data from Kinesis, processing the bulk data from S3, stores it into an Elasticache, and you have an API gateway querying that information from your Elasticache system. This is the cost-efficient design that you can make. And if you look closely to these instances that get the data from the Elasticache and persist it to Dynamo and S3, just in case something might happen to Elasticache, you will notice here that you can even use spot instances for that, because you do not rely on these instances to be available right now. It is okay if you have that within a few hours, because Kinesis will retain the data for 24 hours, and if you have, within that 24 hours, pulled the data off, you are just fine. That's the approach. You separate the fast data layer that you do cost efficiently from the persistence layer that you also do cost efficiently because it has a different operation point. Lots of transactions on the Elasticache, several transactions on S3 and Dynamo. The ability to process tens of thousands of messages per second on Elasticache, and the ability to have a very high durability of data on S3 and Dynamo. Let's have a final look on the numbers I gave you. This serverless design has very low fixed cost. You remember the numbers I gave you, $90 for Kinesis, $130 for Lambda. This was actually a big system. So if you really go to the bare minimum that you have to pay, you would pay $27 for the fixed cost of providing the capacity on the Kinesis, on the Elasticache, on the DynamoDB. And $27 per month is not much if you want to start a business with renting out elephants or so. And the serverless gives you the ability to pay a per message, per computation fee. And in that example, you pay $5 for the IoT and $1 for the Lambda, for each of the Lambdas that you have in this processing architecture. And that's the power of serverless. If you do these architectures, you can really start for small money and scale out your business. If you are successful, if your idea is successful, you can quickly scale out and pay with the money you earn. So these serverless technologies reduce the upfront invest that you have to do in the IT. And this is the real game changer that we have today, because the cloud gives you the opportunity to do exactly that. You do not have to be a big business to start that elephant telemetry thing. You can start with about $30. That's the power. Thank you.